Marketing Officer for Mercator Ocean International. I'm very pleased to welcome you for this debriefing session of the Copernicus Marine Training Workshop dedicated to the Arctic Ocean. So this is a debriefing session. So the objective is to come back to question or blocking point you could have during your practical session, during your 15 days practical session. So today we are with all the experts, Copernicus Marine product experts, to come back to this blocking point, how it works. So each expert will come back to question or blocking point you could have during the practical session or during the webinar. It will leave you sometimes to ask live questions. So the Q&A mode is enabled. So use the chat platform bottom right on your screen and ask as many questions as you need to ask, and the expert will answer. So we are going to begin with our user support expert, David Bazin. He will come back to a question in relation to the website. Then Paz Rotland Garcia and Vidarlin will come back question concerning in-situ product. Then Cécilie Vetre will come back to sea ice product. We will then continue with Laurent Bertino with physical and biochemical product questions. We continue with Oyvind concerning wave product question, and we will finish with Vincent Mopa concerning GIS tool question. So first, to begin, I would like to launch a small live survey. So give me 1 second. Okay, I think all the participants can see the survey. At the moment, you can scroll and answer the question. So it will leave us some feedback, interesting feedback concerning our training format. And we will come back to the results in a few moments, and Fabrice and Mathilde will comment the results. So first question, which Copernicus Marine product are you interested in? So you have all the product, ocean color, physical model product, in situ observation product, wave model product, and biogeochemical model product. Question 2, did you test, run, or one or more practical exercises during these 2 weeks of practical homework? Of course, and more than one. So this is for the good pupils. Yes, at least one. Well, I dropped because it's too difficult. No, because of time, but I surely will. And no, because it's not the kind of exercises that I'm looking for. So just a reminder, you will have access to this Jupyter notebook dedicated to the Arctic Ocean for at least 1 year. Is that right, Fabrice?
Yes, sorry.
No worries. So question 3, after your participation to this workshop, do you feel more confident to use the Copernicus Marine Service products? Yes, no. And one open question, if you are a skipper or if you like this, so do you think the skipper, Jean Le Cam, can use Copernicus Marine physical and wave products to optimize his routes and win the Vendée Globe? So if you don't know what it is, you can answer answer 3. I don't know what you are talking about. Okay, guys, I leave you a little bit of more time. I will introduce you the moderator for the time being, Mathilde Cancé. Hello, Mathilde.
Hello, good morning, everyone.
How are you?
Fine.
And Fabrice, the main organizer. Thank you, Fabrice, to answer my question. How are you?
Fine, thank you.
Okay, I leave you the floor for the time being. And I leave you, the participants, 1 more minute to answer the question, and I will share the results.
Okay, so as Vincent said, welcome to everyone to this debriefing session of the training about the Arctic Ocean. And if you just arrived, we are doing a quick survey on your use of the training material during this workshop, and you can ask all your questions in the chat of the platform, and the experts will answer your questions live during this debriefing session.
Vincent, do we have another survey at the end of the debriefing session?
Yes, it's a very quick one. It's just to have the feedback of the participants, and
Okay.
it will help us to improve our training format, our online training
Yes.
format. So
Yes.
it will be very quick. It's and it's an open question. So leave your comments, please.
Okay, this year was very extraordinary, as Vincent says sometimes, due to the COVID context. And so it was the first time this year we organized this kind of online training workshops. So we run this kind of format, and we hope this format fit your expectation for this kind of training workshop. But if we can improve for next year this kind of format or the material, it's very important to have your feedback and to know if we have exercises for all the levels, for all the kind of participants. So let us know what is your feedback about that. So perhaps we can have the results now.
Yeah. Okay. I end voting and share the results. I think you can scroll down and comment, Mathilde and Fabrice.
Okay, so for the Arctic session, we have a lot of people interested by physical model product and in situ observation product. I mean, I think CI's products are included in the physical model product question. Yes, it's not a surprise to have this kind of results. Mathilde, if you have a comment now on that.
No, it's good to see that there are users of all the kind of products. It means that we we made a good selection of the products for the different exercises. I think this is a good panel of products. So it's fine.
So about the your practice of the different exercises. So, okay, 11% of the people answer of course and more than one. So it's good. you had time to do that, and it's fine. It's fine. Yes, at least one. Okay. No, because of time. Okay, we understood. It's very complicated. This end of this year is very complicated for everyone. But don't worry, all this material and all your access are available until April. Mathilde, is it correct?
April.
End of March 2021. So don't hesitate to come back and try to make some practical exercises. Okay. After your participation to this workshop, do you feel more confident to use Copernicus Marine Service product? Okay. So yes, for more than 50%, and no for the 4%. So for the 4% who said no, don't hesitate to ask question now. This is your last chance to have at your disposal all the experts involved in this workshop, and also David from the service desk. So don't hesitate. It's now your last chance to exchange live with them. You can, after the workshop, contact the service desk by email, but this is the place today, and this is the moment to ask live questions. And do you think the skipper Jean-Luc can use Copernicus Marine physical and wave products to optimize his route and win the Vendée Globe? Yes, for sure. No, it is Yunsu. I don't know what you are talking about. Okay. I know it's not a race very known, only for sailors or for the French people, but this is a great sport adventure. Okay, so let's continue with the first expert.
Yep. So I think it's my turn.
Okay.
Hi everyone. David, I'm not using the video, unfortunately, so I cannot see you. Enfin, you cannot see me, but I can hear all of you and read any questions, such as the one from Michael a few minutes ago on the chat. I wanted also to thank everybody, because by the end of this year, it's pretty difficult for many of us. And for example, just for me, I had I lost the internet connection at home, so I had to go back to the site, the office, to prepare something that I haven't, of course, finished. So I'm going to share with you my screen right now. Let me put that in motion like this. So you should be able to, you should see my screen here.
All good. All good.
Thank you for the confirmation, Vincent. And I wanted to start, yes, because we said a lot of stuff. You also saw a lot of different information coming, everything from the same website, but it's provided by a lot of experts. So it's a very, let's say, broad range of information, expertise, and also level of information. And sometimes what you want is to start with the very basics. So I hoped that there were not simple questions, so that it could help people to get started, either from the chat or for a different question places. But so it seems that for most of you it was fine. But from here, the very beginning is I saw and I received different questions asking, how can I have a little preview of the data? Because there are so many data, so I don't know where to start. And it's very common and it's normal. So here you have an ocean visualization tool. It's something that when you click on it directly, you will get to the, let's say, a preview of the catalog. And here I selected for the purpose of this training, just the CI thickness. And here you have a lot of different buttons. And of course, we are providing different videos to show you how to actually play with the interface. These videos are available from a little shortcut in the widget in the bottom right. And here you have, by clicking here, for example, I will do it and then go back to the purpose of what I was saying at the beginning. You have the different videos here so that you can see the different tutorial about this one was about the color map that you can change. And of course, from here, we can zoom in to the North Pole and we can see the sea ice thickness. And for example, if I was looking for, let's say, some time was ours, some more, you can, of course, have a preview if you're interested into the North Road. Well, maybe you want to know here by doing a left click. You want to see the distribution along the time, and you will get a little preview here about the data. And of course, you can see, okay, I would like to jump here, and it will automatically change the time on the scale for you. And so there are a lot of stuff to discover here. If you don't like this color bar, you can move to, this one might not be very good, but anyway, to another one. And of course, if you would like to discuss with your manager or anyone from your team and telling, okay, I think this product might be interesting for us, you can just send an URL shortcut to your colleague. So you paste in, and you should be able to see the exact same view with the exact same chart here. And of course, you could add many other different layers, which we called for a variable. Well, there are a lot to discover. So this is how to get a preview of the data catalog. And we definitely encourage you to start with at this step, because we're adding many more features every quarter. So it's also good just to come back after a while to see what have been done or what have been added. Then Fabrice also mentioned that here you can get in touch with the user support team. And I'm reading the question right now, but Laurent Bertino and also the other, just to make sure if there is some connection with what I'm seeing right now. Not sure. No. Don't worry, Laurent, you will get, of course, a collected, let's say, information about everything of the practical homework. And so I was telling just that you can reach here, the team. Anything you type in will get directly to someone and not a bot, because what we saw from the COVID crisis is that the more human relation connection we, let's say, provide, the better it is. Because when you're stuck at home or wherever else, it's better to talk to someone than to a robot. Anyway, if you type in, let's say you're in a different time zone and we are not here, so instead of a few minutes here, you see something like in 2 days, because it's Friday on your time zone, but in our time zone, it's Saturday. You can also see here, sorry, type in a question, for example, how to extract, let's say, the data to CSV, for example. You type in a question, and here you will have some learning keywords that will propose you some different kind of articles. And this one is pretty much, well, answering my question. And I can see if I read through, of course, we are not going to do it right now, but I encourage you to do it, is to, from an HDF file, which might be a format that you do not know well yet, the standard for the after observation data, you can convert it to a tabular, regular Excel, to mention just one software, but a CSV file. And so you have here different explanation about how to do it and how to do it with different software. And of course, you can go into details to get something like this, which is actually pretty much as anyone wants, just a tabular file with different columns. And in the columns, you have the values of whatever you have downloaded into your NetCDF file. So we saw how to ask a question if no one is available in the hour. And of course, if you click on see more results, you will land on the Help Center page, where also sometimes we provide some, let's say, ephemeral information. For example, today, the 15th of December, we are releasing two new datasets. And these datasets are pretty interesting for the Arctic as well, because we are also adding new format for the GIS people, the GeoTIFF, and there are, well, a lot of stuff to read as well. So I will let you go through when actually on the time. Then I wanted to, let's clear up a bit here. We saw something from here, very good, a lot of stuff also to say, but let's jump here. For the different materials, because I saw quickly a question about the materials, how can I get them and how can I retrieve them? So of course, the very first step was to copy the data from one folder to your, let's say, working folder, which is here. So I executed this cell, and now I have everything here. Very well. Then there was a lot of very, very well-made video by the Copernicus Marine experts. And I was reading the question, sorry. And so, of course, I hope that you have time to see them, because for every single, notebook, Jupyter notebook, there is an explanation. And here it was for the GIS actually session that two of you asked the question. I was not able to find the GIS exercises, so my colleague is going to answer you, and some answers have already been given in the chat. But anyway, it will be nice for the people who are not reading. And also, there was a question about how do I back up the different training materials on my own local server or computer. Let's say that you were particularly interested into the CIS product here. So maybe that one. You made something you really wanted to continue and to share with other people for a next year course or anything else, any use case you might have, because you change a lot of stuff. So you want to have it and to deploy it into your organization. What you can do is to use this kind of type of command line to actually just, let's say, concatenate all the files into one, what we call zip file, an archive. So when you execute it, for example, here I asked, so I go back here from the File Explorer to my root folder, and I said here I would like to put into the mywork directory, I would like to put one single file which is called mymaterial.zip, and it's going to be done. It's doing the deflation, gathering, collating all the files from this folder. So we talked about the CIS product into one single. So it's taking a bit of time, but you can see here that it's working because the stars is here. And now we have the number. So of course I have now the zip file. And then you're invited to do just a right click here. You have a contextual menu. And if you click on download, then you have, well, it's on downloading the, well, almost 300 megabyte to your own local computers. The access to the Jupyter interface for the question asked by Alexandra is, we're going to give it to you again, but it's always, and it won't change, it's Jupyter-CMEMS, Copernicus Marine Environment and Monitoring Service, and Mercator-Ocean.fr. And from there, you input a credential that you have received, and of course, I've already done that, so I'm automatically logged in. But otherwise, if you do it like Jupyter, you input here your credential. So this is your Alexandra. Thank you, Fabrice. And do you have any other question related to getting started or with the service, or anything else that we could also do to make sure that it's easier for the next, let's say, a member of the Copernicus Marine Service, the new member? I see a lot of questions from my colleagues. So, Vincent, I might leave. Oh, Mathilde, sorry. Might leave the floor to the other colleague.
Thank you, David. Yes, there was a question about someone. Well, it was Laurent, but it's a question that anyone can ask. I have lost the link to the practical homework in their webpage where all the information is collated. So actually, you can find. So maybe David, if you're still online, and you
yes,
have you have still access to the training web page.
So yes,
you can find all the material, the training kit, I would say, on the web page of
Exactly.
this workshop event.
So, for example, I invite you to click on the widget, which is available on any web pages on the bottom right, and I invite you then, second step, to scroll down until the bottom, and you will see the last training of this year, which is this one for the Arctic. And when you click on it, of course, you're redirected to the workshop webpage where there are everything about what Mathilde said just 30 seconds ago. So,
yeah.
bottom
Yes,
right,
you have the participants manual just
here.
Yeah, and you have all the links there to access the videos and the
the related information. Exactly. Also, I saw, Mathilde, if I may, a quick question about the documentation. Where can I access the documentation about the product? I don't remember who sent the question, trying to get it. But anyway, again, here, if you ask a question within the little widget, how do I access, I don't know, I'm trying to write an English question, product documentation. It should pop up a few results. Yes, the first one might be the good one, how to access the documentation associated with a product. So here you will get the different basic information on how to access them. And of course, when you click on one real documentation, so for example, let's do the different steps. I go to the catalog, so I open up a new tab here. I'm going to select the tab. Well, I'm going to do that, click on more info, and then when I reach the page, I'm going to, here it said, yes, go to the documentation and you tab and then the file. So I click on more information. I go to the documentation tab. Here, the first one was broad information. And then here you have the different document. And if you click, for example, here, you should have a list of different past updates. And it gives you a broad idea about the next update, which is going to be. It's about 3 years. So next year is going to be a new, let's say, upgrade of the numerical model. So 2021 is the next update for the, Global Ocean 112 physics analysis and forecast. Thank you.
Thank you. And there is also, I see a question from Pauline. I just publish it if I can. Yeah. Is it possible to have access to previous trainings? So yes, you can. Well, I answer. When you go to the Jupyter Hub, you have access to all the previous trainings. Actually, you can access the exercise of all the regions that were considered for the
yes, and there is also a question about the GIS exercises, and the GIS exercises are tutorial videos available on the YouTube channel of the Copernicus Marine Service. So I think the link are also in the provide you by email after the session, and on the platform, the YouTube page of the Copernicus, you will find playlist of different videos, and you have a playlist dedicated to GIS exercises, not only on the Arctic region, the Arctic Ocean, but also on other regions.
Yes, and just to say, for the GIS training, actually the data that were used for the training are not available. Well, because we just downloaded some sample data, but there is a documentation that goes with the training. I don't know if it's available with the videos, or maybe Fabrice, you will tell us more about that. But we give the information of the products that are used and the period of time And so you can download the data by yourself and then do the exercise with your own data set. So it's a bit different from the Jupyter notebooks, where all the data are stored close to the notebooks. For the GIS training, you will have to download the data by yourself.
Yes, we have to provide this information because I don't remember if the document about each GIS tool is available or not, but I will check that today, and if and the solution is to put all this information available for you on the cloud, and we will make a link, a short link on the videos to access to this information.
Very well. So let me know, Fabrice, if it's not trying to put too much pressure on us. But I think that by 2021, let's say end of January, for the people who are interested into, of course, getting back to these materials for the GIS, you could here on the widget chat ask your question how to access the GIS data, for example, GIS training data. And when you will each enter, for the moment, there is no results, but there will be a result. Okay, so we'll make sure that you can get this data with all the processing explained directly from the website, so you don't have to search anywhere. Just ask us a question here. And also, you mentioned one thing, which was the GIS tutorial playlist, Fabrice. And here it's displayed, and you're right, it's about a different, let's say, a region, the Baltic Sea, the Mediterranean Sea, and of course the Arctic one. And the very, very first question was about how to get the different access to the previous training. And Mathilde, you confirmed that it was possible. And yes, here, you guys were working on this folder, Training Arctic. But if you go just a bit up and you select, for example, the Med Sea, and you're interested into the pollution in the Med Sea, then you go to the physics, and you will get all the different training of the past year. So that is all for the illustrative pictures of what we said.
Yes, and just to add a word about the GIS training. So the idea was to show how to use the CMEMS products with the GIS tool. So we provided examples, and the idea is that is just to show you. Well, we will discuss this later on this morning, but just to say that it was to show another way to handle the NetCDF products with the GIS tools compared to the notebooks, and with the idea that you can reproduce it by yourself with any CMEMS product, actually. So just to show you how to open a file and then explore the file and plot the data. Okay, so thank you very much, David. Fabrice, I think we can move on to the in situ training session.
Yes.
So Paz, Rotan will present, and Vidar will present the debriefing session, yes, of the in situ observation product. So I think we have, yeah, Paz is here too. So hello, welcome to both of you. I leave you the floor.
Good morning to everyone. Well, I'm going to start just, well, hello, Vidar. I didn't have the chance to say you good morning before. At this point, you have to be already familiar with the material we have shared with you that focus on the in-situ observations, the videos, and also the notebooks. Okay, so you have to be already familiar with the content of the in-situ products in the Arctic, and also about how to subset this product in order to download certain files that might be suitable for your needs. We also prepare some notebooks dedicated to open and read some files coming from certain platforms like Mooring, Profiler, and Check Radars. And these are the resulting plots we worked on in the notebooks. And well, I hope you have run the notebooks, and if not, I invite you to do it because they are quite informative. So it's the easiest way to get familiar with the in situ products in general terms and with the Arctic one in specific. The next thing I'm going to do is to answer some of the questions that you raised in the previous session that we had, in the one dedicated to the Arctic product. I'm going to talk about the two first one, and then Vidar is going to answer the two last ones. In the first case, Thomas was asking if we are going to enable WMS service for the in situ products. This is a very large answer, but right now this WMS service is fully or partially available for the in situ products, and it's only applicable for 9 out of 16 in situ products, and it's not going to be extended for the rest of the in situ products. What we are going to expect is for the next year to have AirDAP services. So this is probably the best way to query in situ products in the future. I have also added in here the full list of the products with the WMS details, which ones have WMS enabled fully, which one has WMS enabled partially, because it's only dedicated to the latest collection, the last 30 days of data, and which ones are not currently providing WMS access. So you have in here the full list just in case you want to double check the situation. The next question was about the northern
Sorry, Paz?
Yes?
Yeah, sorry. There is some participant who see you upside down. Could you switch off your camera maybe and switch it back?
Oh, yes, of course.
Is it better?
The same situation, or
is it better?
Okay.
For me, that's okay. But
Okay.
let us know on the chat if it's okay, or else I will ask to switch you. So you can switch off your camera, no worries.
Okay.
Sorry about that. You can continue.
No, don't worry. It's going to be funny to see the recording of this. Well, and then the next question was from Katarina. This person was interested in having data along the northern sea route. And I just took some snapshots of our visualization tool, so you can see more or less the data that is available along this route. And at the beginning and at the end of the route, you have fixed station data, so like data reported at an hourly basis, basically. But when you go to the middle of the route, you end up having transitory data, which is reported by mobile platforms, like, for example, drifters mainly, and also some profilers. So it can be a little bit sparse in the middle of the route, although at the beginning and at the end you have more data, of course. So I hope these answers are useful for you. And I leave the floor to Vidar for the next ones.
Yes, good morning, everyone, and thank you, Path. I can start by adding a bit to this question that, of course, having operational data from the Arctic is quite challenging, especially from the surface, for obvious reasons. So that is one reason why this is our data sparse area. The other one is related to also this area being in the Russian sector. So there are some challenges of getting data from Russia open available. That is one challenge as well. But we keep adding the data that we get our hands on and that we can share also with everyone. Also, there is an initiative that is started this year and will go on for next year, which is called Synoptic Arctic Survey, which aims at getting a synoptic overview of the whole Arctic, which will also include this northern sea route area. So there will most likely be more data available from next year. But again, operational data is difficult from this area. Okay, the third question we got that we are addressing here is about the data quality control. So the question was if the data control is on an expert level or metadata check. So the data quality control is performed on the data level. So what I can say is that we get data on an operational basis, which is our near real-time product that goes through automated data quality control because it's an operational data stream. And that is what you find in the near real-time data stream or the latest data. In the history catalog, you will find, as they arrive, delayed mode quality control data as well. And then in our reprocessed data products, in addition to that, we add another layer at the CMEMS side of data quality control, where we use, for instance, automated quality control procedures to identify suspect values that are then visually inspected and quality controlled. So that is the kind of layering of quality control that we apply. And of course, all procedures that are applied from Copernicus Marine side are documented in, for instance, the quality information document that you find along with the data on the website. And of course, the data quality control that has been performed on the data provider side is not always within our hands if we are not the data provider ourselves. So for that kind of data quality control, we have to refer to the originator of the data, which is given in the metadata. But as I said, we add a separate layer on the Copernicus Marine side to make sure that all data are quality controlled before they arrive at the website. And then we had the last question, and this is about the structuring of the data. The question was, where can I find the data separated by parameters as in the reprocessed product? And the short answer is that you can't, because in the near real time we have decided to include all parameters into a multi-parameter product. So all parameters are represented in the product. But what you can do is to use the index files. There's one index files for each catalog or directory, index latest for the latest directory, index monthly for the monthly directory, and for the full directory, the history, you have the index history. And in there you will find all the files, name of the files, and the content of each file. So in there you can search for the parameter you want, for instance, oxygen, if you want to look at oxygen, and then you can identify all files in the history directory that has oxygen in it. And then you will exclude, of course, all files that do not contain any oxygen variables. And we have a notebook example on how to do this. So I would ask you to check that out if you want to look at how that works. So that were the questions that we were addressing from the last session. So we are open, of course, also to new questions that you can write in the chat now on the live, and then we will try to address them as best as we can here.
Thank you, Pat and Vidar. I don't see any questions about the Institute products for now. So if you have a question, it's time now to write it down in the chat. Last chance. Or then you can write it later on and you will have a written answer in the chat, but it's better when you have a live explanation. No, for the moment, no question. Maybe I have a question for you. If I have data that I want to share with the whole world, can I do it? If I have in situ data in the Arctic Ocean and I want to provide them to the CMEMS portal, is it possible? And how can I do it?
Yes, of course. Indeed, you have to contact IMR. VDAR belongs to IMR, and they are in charge of integrating this data. So if you have data, you have to contact IMR. And I think in one of the replies, we provide this IMR service desk email, or if you cannot find it, well, I'm going to type it now in the chat so you have it in hand. I don't know if Vida, you want to add something in this sense?
No, I think that's clear enough. It's the Institute of Marine Research in Norway that's responsible for the Arctic part of the in situ TAC. So if you have any data that you cannot find in the CMEMS database and that is openly available, then please contact us and we will make sure to include that in the database.
Okay. We have a question from Ekaterina. Yes, thank you for sharing. What about the code to process, visualize the data? Do you have a channel to share codes?
Yes, we are maintaining a GitHub, actually. So we are uploading the code we produce for these trainings and others. Because sometimes users request some piece of code, and we are uploading this to our GitHub. So this can be reachable also from GitHub. I'm going to put it also the GitHub in this chat.
Yep.
Oh, that wasn't a question. That was an answer about the email.
So you have the address here. Okay. Sorry, this is to write to the answers. That's not.
Yes.
Okay.
This I'm going to provide also the GitHub. It's just I'm very bad at typing in this device, so it's going to take some time, but I'm going to put the URL of the GitHub, okay? Yes, no problem.
Okay, thank you. I don't see any other questions, so maybe we can move on to the next training session about the sea ice product. Thank you very much, Paz and Vidar, for your explanations.
Thank you.
Now we are welcoming Cecilia Petre from Met Norway, who is responsible for the sea ice observation product. Hello, Cecilia.
Hello. Hello, everybody.
Thank you. So, sorry, I would just very briefly present the training content, the training material content, just in one slide, and then I leave you the floor with the sea ice product questions. So again, for the participants, you can ask all your questions in the chat during this short presentation, and we will answer it later on. So just to remind you that for this in this training material, we proposed you to use the the Arctic sea ice satellite observation product and to see how to handle the NetCDF files, reading and plotting the data, mapping the sea ice fraction from different products, so different sea ice observation products, and also computing monthly means and doing some comparison with the physical model outputs about the sea ice information. So that was just a quick reminder, and now I leave you the floor, Cecilia, with the questions.
Yeah, okay. So thank you. I selected some questions from the previous training session on the 1st of December and a couple from the chat on Mattermost. There were some questions that were in the previous session that I didn't manage to reply to. So anyways, there was a question from Amy who asked in the ice type product which is coming, if it's possible to have a distinction between fast ice and drifting ice, or if there's some plan for the future. So for this product, we don't have plans to, as such, to distinguish between fast and floating ice, but fast ice is marked manually in the ice charts. So we have the gridded ice charts. This is the product which ends with 011002. And in this product, the fast ice is given as 100% concentration of ice. So typically, this is something you can find north of Greenland. So question number 2 from Sarah. I was talking about the time series for the ice surface temperature and sea surface temperature, which is also coming in a few months. She asked which period would be covered by this, and so we've recently heard from the producer that this period will be from 1982 to 2019, and spatial coverage and grid resolution will be the same as the existing near real-time product. Question number 3. This is from Ekaterina, who was asking about basically how to tell what is the acceptable difference between two ice products. This is from the exercise done as homework. So the best answer we have for that is that we have collected all accuracy and uncertainty estimates in what we call the quality information document, which is to be found online. Quality information for the sea ice products varies. Some of the products will include quality information within the file available for download, and others are validated more irregularly, because in the Arctic it is a challenge that there are a few in situ observations that we can use for validation of our satellite products. So here's a sort of long question also from Ekaterina, who's planning to compare sea ice concentration from available producers against an external sea ice concentration provider. And she says they're thinking about using the high resolution sea ice charts from the sea ice services. And if this would suit the purpose, or maybe there's another product that could be recommended. And so I just confirm here that yes, absolutely, the high resolution sea ice concentration product is probably the best product for comparison products. We also have global product, which is popular for downloads. This is an automatic product, which is good for data assimilation, but the resolution is much coarser. It's at around 10 kilometers grid size. So there's a big difference in the resolution here. So the benefit is that since it's automatic, it is daily updated. So I just provided some links here. So where to find the product. It's not always immediately easy on the portal to find products. So here's the direct link for the 011001. This is the global 10-kilometer resolution product for sea ice concentration, drift, and so on. And also, as David was demonstrating earlier, there's a very nice viewer for sea ice products here. So here's also the direct link, but I think it's also easy to find from the portal. No, not thank you yet. I noticed in the chat today there were also some questions. Ekaterina was asking when sea ice products are expected to be updated, including the documentation. This varies a bit according to the producers of these products, but CMEMS itself has usually 3 annual updates. So one is actually now, today, and the next one will be in May next year. So for our CS products, it will depend on whether there are new sensors, satellite sensors, data included in the products, or it could be that the producer has improved the resolution in time or space for the products, and so on. So it's not updated all of the products at the same time, 3 times per year. Right, so today, as I said, there are some updates of the Baltic CS thickness automated products. There are some updates to the Arctic Ocean ice chart product, which includes some new variables. So basically, if you look at the link provided by Fabrice in the chat, you can find a list of all the updates that are due today. So, yeah, other questions that may have come?
Yeah, we have also. Oops, sorry. Like we had two people managing the questions at the same time, so sometimes it doesn't work.
Okay. Okay, for the areas around Svalbard, could you please elaborate if some areas are more accurate or maybe better known than the others, and what areas are more uncertain? This is a question for example, the sea ice service expert, which who may be available here. But well, the sea ice edge around Svalbard is, I think, it's pretty much the same quality, but I guess it will vary a little bit from day to day. But I don't think I can answer that question directly right now. And where the information could be found, again, I would refer you to the quality information document. Okay, here's a reply from Nick, who is the expert on this product. Yeah, so areas around Svalbard have higher resolution satellite coverage from Sentinel-1 on RadioSat-2 on a near daily basis.
I see that Nick is with us, so maybe if you want to say something, Nick, if you want to add a word. Yeah, hello. Your microphone is muted. Your microphone is still muted.
Okay, so Nick doesn't have an operational microphone.
So sorry for that. Okay, any other question about sea ice? for Cecilia.
Okay.
Okay, so thank you very much, Cecilia. And I don't know, we are supposed to have a short break now, but I don't know how Fabrice wants to deal with it because we are a bit late. So Fabrice, if you're here.
Yes, we can ask to Vincent if he's on your agenda, Vincent. Do you plan a break or not?
But we are a little bit late, but there is a lot of information for the time being. I think the participants need like a 5-minute break, if you don't mind. And after we will continue with Laurent Bertino for the physical and biochemical products. Okay, so a quick 5-minute break and we'll come back to you.
Okay, so 5-minute break, and you can already start to write down your questions about the physical and the biochemical products in the chat. So see you in a few minutes.
Okay.
party.
Okay.
We are back.
Yeah.
Mathilde?
Yeah. So, hello again, everyone. It was a very short break, but just to refresh. And so now we are going to talk about the physical model products. So I'm with Laurent Bertineau from NASC.
Morning.
And hello, Laurent. And as for the previous presentation, I was just remind you very quickly what we proposed in the training material about this product. So again, the idea was to explore the NetCF products and with the Jupyter notebooks, and to show how to map the various parameters, so the temperature, the CI fraction, and so on, and look at the evolution of this information across the time. And also we showed how to plot vertical profiles and punctual time series of the parameters, so you can compare the evolution in time of the CI's thickness, for example, and the water temperature. And so now I leave the floor to Laurent.
Yes, thank you. So you actually, I said, yeah, a comment on this profile. So the profiles are very crude. It's only 12 levels. It's not really something that was, say, meant for, say, very detailed examination. But some products will start upgrading to 40 vertical products today and again in May next year. So gradually we're including higher resolution. To reassure you, that is not the resolution the model is using internally. It's just some standards that were defined more than 10 years ago to use the Levitus levels to share data between us. So that's still a last remnant of that in the ArcMFC. And yeah, and then another comment on the time series here. I see that you've picked a plot one point in the Kara Strait. So that's the little strait between Novaya Zemlya and mainland Russia. So it's a place where there's water exchange between the Kara Sea and the Barents Sea. So that's yeah, it was interesting to see it's getting warmer there and thinner ice, according to the model. The questions I had was from Lasse Rammstein. Is there any reason to use one product or the other? So FIS 002001 was the older product, it was what we call Topaz 4, and 002011 is a newer product, NextSim. So these two models are living different different cycles, different updates. So since November, Topaz has estimated CI thickness from CS to SMOS, a new product from CI stack, but NextSim doesn't do that yet. So I would say that most of the products that I've shown round one, so the concentration and drift are more accurate in NextSim. But for ice thickness, if you want ice thickness only, then it's probably more accurate in Topaz 4. So because it does assimilate CS2 SMOS data. But for drift and edge, use the latter. And the other thing, the reason why we have two models, so there's a model which is a coupled ice ocean model, so that makes it much more expensive to run. And NextSim is provided here as a standalone CIS model. So if you are looking for exchanges between sea ice and ocean, which, well, is, as I say here, is quite specific, you should use a model that is coupled ice ocean. But otherwise, yes, as I said, the NextSim is, say, all the better options, more accurate, higher resolution. And the day that NextSim assimilates ice thickness, then there will be no reason to use Topaz 4 for the sea ice variables alone. Next question from Marta was whether Topaz and HiCom are the same. So here we should avoid, say, language confusion. The model source code is called HiCom, and the implementation is called Topaz. So HiCom is an open code for ocean modeling. It's used in the US a lot and by the HICOM community and the NRL forecast system, the GOFS 3.0, 3.1 global forecast systems. And it's commonly referred as the HICOM forecast. But HICOM is a source code, and we have our own configuration for the Arctic MFC that is shared between the Lancer Center and Met Norway. And we use it, we call it Topaz for disambiguation when it includes all of our add-ons. So the interfaces to the surface, the grid, the assimilation system, the ensemble cannon filter. Then we call it the Topaz system. And that was the two questions I had for this year. But if you have more questions, I can still answer. More accurate. What do I mean by more accurate? So that's a question referring to the accuracy of the ice thickness, I guess. Yes, ice thickness. So it's more accurate in the sense that it would be closer to the CS2 SMOS satellite dataset, which itself has been calibrated on a lot of in-situ data. So we cannot guarantee with ice thickness that it's better everywhere, because the even the satellite data have some challenging data to obtain. So and knowing that the ice thickness has a lot of small scales and meter scale features, it's difficult to guarantee a very high accuracy everywhere. And so I should refer to the the most accurate we have is the observations today, the satellite data, and there's a quid for these data sets, which would show what how it performs compared to in-situ measurements. And at best, the model can be quite close to the satellite data, but probably not more accurate than the satellite data itself. And there may be areas where the product is working less well, but there's only a few points of ice thickness available in the whole Arctic, so it's difficult to say in more details where.
And I have a question for you, Laurent. Is there any uncertainty information provided in the model? Or?
Not today, no. That was another question that we had on the chat. The satellite data have some form of quality flag or uncertainty field, but the models are all deterministic today. Although we do run Topaz as an ensemble of 10 members in forecast, but there is no mechanism in CMEMS today to provide ensemble data. It will be very costly as well, so it needs a bit of careful thinking.
Yeah, thank you. I don't know if there are any other questions. I don't see any more questions for the moment.
Anyway, the next speaker is me again. So
yeah. Yes, that's why I was just thinking that maybe we can go to the next presentation about the biochemical products, and if some participants have questions about the physical model, you can still have you still have a chance to ask Laurent. So again, for the biochemical products, so Annette Samuelson did the presentation on the 1st of December, but she was not available today. So Laurent is.
Yeah, she sent me apologies to the group here because she's taken on another meeting with Mercator and biogeochemical data simulation working group. So I will try to answer as well as she would have done. But so yes, that plot is yours, Mathilde.
Yeah. Yes. So again, just to say that in this training material, we proposed to show how to map the biochemical parameters and to see the evolution of the oxygen and the chlorophyll, for example, over the year. And we also showed how to combine this information with the sea ice information from the physical model on maps, and also we plot punctual time series of the parameters in different regions, so you can see how you can see the evolution over the time, and how some parameters are used by other parameters to grow and to decrease. So I leave you the floor now, Laurent.
Thank you, Mathilde. So yes, there were a few questions, not even a question for the models, but it's a question about chlorophyll, which I guess was better replied here, whether there's plans for developing case 2 waters algorithms for ocean color. And so Edson probably knew that these algorithms are regionally developed. There's a reminder, case 1 waters are the open waters of the open ocean. That's where the properties of the water are rather well known. There's very little sediment in case 1 waters, but case 2 waters actually englobe a large variety of different water types with different amount of sediments, yellow matter, and other things that I actually not an expert of, but that requires a lot of specific regional tuning for the river contents, the optical conditions of the waters on the coast. And I'm not aware of a case 2 algorithm that would work for all of the coast along the Arctic. So that's what I say. It's it's not impossible, but not available as far as I know. And next question is, why is it that the biogeochemical reanalysis are of coarser resolution than the near real-time data and the physical reanalysis product? And that's because of the cost of running the biogeochemical model. So if you are running a physical model and start coupling it to a biogeochemical model, the components of the biogeochemistry will be additional tracers like temperature and salinity that will need to be advected, mixed, and follow all of the operations in the physical model. And the advection is a costly operation in a physical model. When you include the whole biogeochemical model, like a Cosmo, this multiplies the cost of running the model by a factor of 2 or 3, something between that. And when you read questions like we had this morning, say, is it possible to add dimethyl sulfate as, an extra variable? So it means that we need to add, again, more tracers, and that adds to the computational cost. So the ecosystem models that we are running here, biogeochemical model, that's the strict minimum models to represent the primary production, but it cannot represent all the complexity of the ecosystem. So in addition to that, we use advanced data submission in the reanalysis product, the ensemble canon smoother, and that takes, say, 80 members, and it's run twice for each cycle to run as a smoother. So that means that we cannot run that reanalysis at as high resolution as we want to do. So it means, the reanalysis biogeochemical product will remain coarser resolution. It will increase in resolution over time, but it will never be as high resolution as the real-time product, which is not running this ensemble smoother. And that was all the questions I think I had, unless there's more questions on the chat.
Thank you, Laurent. I don't see any other questions for now. I had one. What kind of data do you use to validate the model? The
biogeochemical model? Yeah, so we use the in situ data from the cruises and as well BioArgo data that are now in the in situ TAC, and that makes, say, that doesn't give a whole coverage of the whole Arctic. It's mostly in the Nordic seas and say the European waters, but that gives profiles of nutrients, chlorophyll, and that's as much as we can do for validating the model.
Okay, thank you. And are there some comparison with the ocean color satellite observations?
Yeah, there are some. If you want to see more, say, matchups between ocean color and in-situ data, you should go to the quiz of the ocean color attack. That's where you find most of that. But yes, when we have both satellite and in-situ data, we actually can do a little comparison.
Thank you. Any other questions on the chat? Don't be shy. No?
Yep.
I don't see any.
Yep.
So, Laurent, if you have something to add, you can.
I'll just leave the floor to Yvan.
Okay. Thank you very much, Laurent. And welcome, Ivan. Well, the
Hi,
wave
can you hear me?
presentation. Yeah, we can hear you. So for the participants, if you have questions about the wave product, the wave model product, you can ask them in the chat. Again, it's your last chance to ask live questions to Ivy for this training. And so I will just briefly remind you what we showed in the Jupyter notebook for these products. So the idea was, again, to show how you can read and explore the netCDF files and map the significant wave height and wave directions during a storm event. And also we showed how to create a GIF animation with this significant wave height increasing during the storm event. And then we also showed how to plot wave roses and time series, and also combining the sea ice information with the wave information. And so I leave you the floor, Ivy, for the questions. Thank you.
Thank you. Let me start by saying that I think you helped prepare some quite useful exercises on the Jupyter notebook. The first question I got was whether there is access to the wave buoys that I mentioned in my presentation along the Norwegian coast. I gave two different URLs to where we do present our wave measurements. They're actually quite scarce, these measurements, that wave measurements along the coasts. And the main projects along the Norwegian coast has been for what is known as the fjord crossing project, which is a huge infrastructure project, which means that they have to map the local meteorological and oceanographic conditions along the west coast of Norway. So those are archived on the Threads server. There is also another buoy which sits separately to that, and I gave an example in my next slide of the comparison, just to give people a feel for how wave models and wave observations typically how they compare. So this is not a statistical comparison. This is just the last few hours actually of yesterday, where you see the wave measurements of the wave height in blue and the wave period in green, and the dashed lines are the model forecasts. So you can see that in this particular case, the wave forecast is slightly higher than the observed wave height. And this brings me to a question which came up this morning in a direct message, which I think is quite relevant. So I would like to switch, if I can, to my screen. Is that okay with you, Mathilde?
Yes, for sure.
Right. Yeah. Let me see if I can do this.
That's live experiencing, so.
It's very exciting for everyone present.
Yeah.
Since I was able to do it last time, unless I've degenerated in the meantime, I should be able to do it now as well. But there's a screen sharing button. Here we go. Okay. All right. So the question then, can you see this?
Yeah, it works.
Now coming up. Can you now see it in full screen mode?
It's
Yeah,
loading.
great.
Yeah, it works.
So I had a couple of excellent questions this morning. The first one is, in the WAM model, parameters describing waves are in the form of mean values, for instance, mean period, significant wave height, and so on. So the question is really, as I interpret it, that the user who asked this question is interested in getting standard deviation values, in other words, climatologies. So I've chosen to answer that in two ways. First, it is true that when we talk about the mean period and the significant wave height, they somehow represent averages of the sea state. And that's because a sea state is a very complex thing. There will be small waves, there will be large waves, and there will be all kinds of waves in between. That is what is known as the wave spectrum. So in order to come up with some snappy summary of the sea state, you typically give the significant wave height, the mean period, and maybe the mean wave direction. But that, of course, doesn't mean that there aren't waves going in other directions and waves that are smaller or taller than the significant wave height. And that's what is known as the short-term statistics of the sea state. So in other words, those are the average properties, if you will, of the sea state right now. But I believe that and I've tried to answer that in on my screen here, but I believe that the person asking the question is really after something else, namely what is known as the long-term statistics. And that is just like you might be interested in how the temperature varies throughout the year, or how the temperature trend has been over the past 30 years. You may be interested in a trend in the significant wave height, or how much significant wave height can be expected to vary for a given time of the year for a given location. And that's what is known as the long-term statistics. And to get to the long-term statistics, we've produced what I presented last time, the hindcast product. And that hindcast product is a long wave model run. It's really like a wave forecast or any kind of forecast, only it's run for the past instead of for the future. And it's run over a number of years from 2002 until 2019 as it stands right now. And this means that you can get statistics on how much the significant wave height vary from one year to another year for a given location, or how much does the wave period vary over the year, for instance. And I believe that is really what this person is after. And the comparison against satellite altimeter measurements taken with the Sentinel satellites is an excellent way to compare the wave model to reality, and that's also in this question. And it's true that all of these, both the wave hindcasts and the Sentinel wave measurements from altimeters are all available through the Copernicus and CMEMS portal. So that's the first question. The second question by the same person was, it seems that there are two world models and systems for ocean wave prediction. The first being the NOAA Wave Watch 3 and then WAM Maritime. I'm not quite sure. I'll try and clarify, as I saw that Laurent did as well. There is a difference between a model code and a particular implementation. Like Laurent made the example with the HICOM code and the Topaz system. Topaz is the implementation, but HICOM is the model, the ocean model code. That's the case with wave models as well. There are typically two leading wave model codes out there right now. There is WAM, which is the oldest one, and then there is WaveWatch 3. And then there is SWAN as well. I shouldn't forget SWAN, but SWAN has perhaps more of an engineering approach to things. It's used more for nearshore studies, but for global ocean forecasts or wave forecasts, those are the two systems: the WaveWatch or WAM. ECMWF run a version of WAM, which they call EasyWAM, because they've made several changes to it. So you could say there are maybe 3 or even 4, but they are very closely related to each other. At present, there are at least 5 global operational wave forecast systems and a number of regional ones. I've listed the global ones that I know to be presently running, and to focus on our products, the forecast model on 3-kilometer resolution, which I've listed, uses winds from ECMWF for their forcing. So then the question of whether those forecasts are compared somewhere, or whether this information is linked. There is a comparison project done by ECMWF. There is, of course, a link in the information between those models, because the wave models all depend on winds. So if the winds are good, then you must expect them to deliver similar results. But they're not linked in the sense that that they are somehow dependent on each other. In fact, the wave code, or the codes of the wave models, are quite different. So I hope that answers the 2 questions I got this morning. I would like now to see if there are any further questions. There doesn't seem to be any questions on the stream right now.
No, I don't see any other question. But thank you very much, Øyvind, for this nice addition to your presentation. It's very interesting to see all these different models and to better understand the context. It's really good.
Yeah.
Yes, we have a question about validation of the models.
Yes, there is Waveboys, Hindcast, Satellite, and more on the validation of the models. I would say that the Sentinel satellites are becoming very important for data validation, as if I can get my presentation back. I think I had a slide in my presentation, which is yeah, that's no, sorry, not that one. I want to share my own screen again, if time permits. Let me see.
Yes, you can share your screen.
We have a few more minutes.
Yes, yes.
This is an example of how wave models are typically compared. On the left-hand side, you see a typical scatter plot. So on the x-axis, you have the wave model. On the y-axis, you have satellite altimeters from the Sentinel satellites altimeters. So what you can see here is that when the wave model predicts high waves, a significant wave height somewhere in the vicinity of maybe 12, 13 meters, then typically the satellite altimeters tend to observe wave heights around 12 to 14 meters as well. So if you're close to the 45-degree line, the one that is stippled here, it means that you are pretty much bang on the money. It means that your wave model is lining up with the actual observations. So satellite measurements are excellent for that, because they provide global coverage. they provide coverage in all kinds of locations where we can't afford to put wave buoys. But we would also like to know, how do wave models perform compared to wave buoys? Because wave buoys are typically, well, first of all, wave buoys are it's an older technology, so we know pretty much how they behave. The other thing is that a satellite flies over, and 100 minutes or so later, it does another turn around the globe, and it'll be covering a different patch of the ocean. So if you want continuous coverage of a certain location, then you need a wave buoy or some other in situ measurement. So on the right-hand side is a similar plot where you have the wave model on the x-axis again, and then you have wave measurements from various offshore platforms in the North Sea and the Norwegian Sea on the y-axis. And again, you can see that the wave model is lining up pretty accurately and pretty close to the wave measurements. So both of these two data sources, the satellite measurements on the left and the wave buoys on the right, are important to validate the wave models. To the follow-up question about wind conditions, I'm going to interpret that as, do wave models behave differently under strong winds or under weak than under weak winds? And the answer to that is that yes, they do. They do tend to obviously for a little bit. As you can see, as the significant wave height varies on the x-axis, you can see that there isn't a perfect one-to-one match with the observations. But wave models tend to behave quite well all the way up to something like at least 12, 13 meter significant wave height. To get beyond that, the question is really becoming a rather complex one. We are not, in fact, not 100% sure of how wave models should behave as you get into really
it seems
strong winds. And it's an active field of research. Helps to be good tools. Yeah. Okay. I think that's
Thank you.
there are a couple more questions here. Are there any known weak and strong areas of wave models? Or can you hear me?
Yeah. We can hear you, but it's
yeah.
It seems it's not so good for the moment.
Maybe stop sharing your screen, Oyvind.
Yeah.
Okay. I have had some problems with my network recently. It could be that I have a network problem.
It's much
better. Is it better now?
Yes, it's better now.
Okay. Thanks. Okay. So there are a couple more questions here. Are there any known weak and strong areas of wave models, for instance, wind conditions in some specific geographic areas? I think I partly answer that. But as for weak and strong areas of wave models, I could also mention that very long propagation of swells over very long distances is challenging. So when you have waves that propagate over the world oceans, it's hard to model them correctly. Can you hear me?
Yeah, we can hear you.
Yeah. Okay. Yeah. All right. Another question here is what innovative future for space satellites in relation to the observation of solid Earth and ocean, one planet?
Well, that's a very generic question.
It's a very general question. I'm not sure I'm able to answer that.
But I had a question for you. Do you use CFOSAT satellite observations?
We do for the. You mean for the model validation?
Yeah.
Yeah, we do. Okay. We have included CFOSAT in the. Yeah.
Okay. Yeah, I'm sorry. The connection is not so good on your side. I think, Eivind. So
yeah, I know there's something going on here.
Yeah,
I can try and turn off my. I could turn off my video and see if that improves things.
Yes, but we heard that yes, you use this CFSS data to validate the model. So okay.
Yeah.
Thank you very much.
Thank you. My apologies for the poor connection.
No, it's fine. It's fine. We heard the principal information. So that's really great. Thank you very much.
Thank you.
We can move on to the last presentation about the GIS training. So I welcome Vincent Maupas from Noveltis, who prepared the training material. So again, we apologize for the fact that the data were not directly available to do the training. Actually, if you want to do the exercise, you have to download the dataset by yourself, and then you will be available to able to do the training and to load the data into the GIS system. And so I leave the floor, or maybe Fabrice, you want to add something?
Yes, I wanted. I would like just to add something because I worked during the previous presentation to upload all the documentation about the GIS training workshop and the tutorial videos. So now all is available. So if I can share quickly my screen to show you this. Okay.
That's very good news.
So I try to share my screen now. Why I can't share my screen? Okay, no, I'm not able to share my screen. So don't worry. You have to go on the YouTube channel of the Copernicus Marine Service. There is a playlist of with all the GIS tutorial videos, and on the first videos of each training material, you have the link to the document made by Vincent and Noveltis to explain you all the data used in the tutorial videos and all the things Vincent show in the video. So it's available. It's online now. Sorry about that. Again.
Great. Thank you very much.
Good news.
And so now we can give the floor to Vincent, who will present the training content and also briefly the training content and the questions we had about this training. Thank you, Vincent.
Thank you very much, Mathilde. So and thanks again for precising where the data are and made them available for the training. Because yes, you need the data, because the training was really the objective of the training was really to help you to handle the CMEMS data and put them in an open source GIS application like QGIS, and handle the data, display, make some interaction with them, and put them in context also with other data. So the training is in QGIS. We don't use ArcGIS because ArcGIS is a licensed software, and QGIS is free, and it has more or less the same functionality. Okay, ArcGIS is a bit more advanced, but QGIS is very comprehensive now. So this training is about Arctic data. So we use the the physical model Arctic CMEMS data, which is now available, and we put them in context with maritime boundaries, shipping routes, and natural resources and industry data as well. So thank you very much. I had one question from Edson. The question is whether the product, if the product is a WMS, can it be loaded directly into ArcGIS or QGIS? The quick answer is yes. Just for the people who don't know what WMS is, it's a web map protocol, so it can be it's the way to display data from which are actually stored in a remote server. So it's basically, instead of downloading the data as we in NetCDF, some of the data are available directly from the server, and you can load them in QGIS and probably in ArcGIS as well, and handle, display, do whatever you can do with the data, the same as you do with the NetCDF, basically. So yes, it's available. WMS is for the map data. It's also there's also a WMTS, which is for the tiled maps. So it's a bit more advanced, a bit faster if it's available, and it's also available in QGIS. So yes, you can load. It's very easy. You just go to the layer menu, like you want to add a new layer. You add a new layer, and there is a menu which allows you to select the WMS or WMTS, not ST, WMTS layer. Then you need to enter the URL. Because WMS, it's like HTTP protocol. It's based on HTTP, so you need a URL, and normally the server gives you the URL. So, for example, in CMEMS, the ice concentration data are exposed in WMS, and you can find the URL on the server. So you just put the URL in QGIS, and then you select it and add the layer. I think ArcGIS is doing exactly the same, but I cannot really confirm because I don't have ArcGIS. Okay, so if you have any more questions, I would be happy to answer, if I can.
Thank you, Vincent. So the idea of this last slide is to say that in the training, we showed how to open NetCDF products from CMEMS, and also how to add WMS layers from external websites. But there are also WMS layers corresponding to the CMEMS products that, of course, can be loaded into the GIS system.
The same way as it is explained in a training.
It's another way to look at the data. So I see there is a question about future development of Jupyter Notebooks exercises linked with QGIS. So I don't know the plans on Mercator's site regarding future QGIS trainings, but actually this is possible. It's possible to link the two systems. So let Fabrice maybe answer this question.
I'm not fully aware about this this possibility, so but why not? Why not? We plan to continue this kind of workshop next year, and to continue this kind of to provide users and participants this kind of exercises on GIS tools. So yes, perhaps it's a way to explore.
Yeah, GeoPandas is it's a Python library, so it's an extension to Python, and it's very very powerful. And it's so you can have same as in QGIS, you can handle geographical data. And because it's Python, you can include in Jupyter.
Okay.
Notebook.
Okay, any other questions about GIS training? It's your last chance now. So just to mention that there are 2 other GIS trainings available on the Baltic Sea and on the Mediterranean Sea, where you can have a look at different products and different ways to map them with QGIS. So it can be also a way for you to explore these other products and other ways to map them. And the videos are available at the same link as provided by Fabrice in the chat. So no other question. So, thank you, Vincent. Thank you very much.
Thank you very much.
And Fabrice, give you the floor. Or?
Yes, this is the end of this debriefing session. Vincent can join us now. Yes. So
I think we have a survey to announce.
Yes. Just to finish, I want to launch a small survey because your feedback are important. So this is 2 small questions. Let me see. Where it is.
And it was our last live session of this year for this new format for this training workshop due to the COVID crisis. We adapt this year the training workshop format to this full online workshop. So okay, we have certainly improvements to do for the next year, but it was a new way to make this kind of workshop for us. And thanks to Vincent and all the partners involved in this project, and all the co-organizers and the CMEMS, the Copernicus Marine Service experts. It was a big success. We can say that because we were able to reach around 1,400 participants, so it's huge, and we provided around more than 60 Jupyter notebooks and tutorial videos. So there is a lot of material available now. So and we will continue next year this kind of training workshop, but with a bigger region, because we're going to change a little bit and see what the outside Europe users have in mind to play with our data. And so next workshop will be a global one with a focus on the regions of Asia, Africa, or South America. So okay. Big issue, big project for next year.
Thank you, Fabrice. Thank you. So what will happen next for you, the participant of this training? You will receive a thank you email from our webinar platform with the recording of the session and the attendance certificate. Later on this week, I will edit a summary of the training where you will find all the material and all the links needed, plus all the question and answer we did during the debriefing session. As I said at the beginning of this training, you have access to the Jupyter Hub dedicated to this training during 1 year, so feel free to practice. This is done for that. Once again, we have very, very good user support in Copernicus Marine Service. David Bazin, our user support expert, did the demonstration at the beginning of this training, so do not hesitate to write them an email or to use the chatbot from our website to ask as many questions as you need to ask. Okay, just to finish, we'll hope that 2021 will be much better than 2020. So I hope that this will be much better. I cross my finger, and I wish you Merry Christmas and Happy New Year, and I hope to see you, all of you, online next year for our next training. So thank you very much. Mathilde, if you want to add something, this is your turn.
Yes, thank you, Vincent. Yes, I wanted to thank very warmly all the CMEMS experts who, again, take the time to answer all the questions and, very thoroughly. It's very interesting. And all the participants for attending this debriefing session. Again, don't hesitate to ask questions about the training material, and we wish you all yes, very very nice end of year, and Merry Christmas, and and Happy New Year, and a good 2021.
Yes, same for me. I wish you a Merry Christmas and Happy New Year, and stay safe. Thank you, Laurent. Bye. Thank you, everyone.
Thank you, everyone, and bye-bye.